Hello students, today we'll solve this question number 2 from assignment number 2. Now what this problem statement says, in this question they have given the position of the origin. Okay, so with respect to the position of the origin, we'll find out length, width and height. How much is the length, how much is the width and how much is the height. As the orthographic views are given in first quadrant, rather by using first angle method. So herein we'll find out the length. So this will be the front view, this is the front view. So wherein we'll get the total length comes out to be equal to 50 millimeter. In front view, as we see, length and height, so we'll find out the total height. So herein this is 5 millimeter, so 5 plus 10 plus 10 plus 20 plus 15. So here it is 25, 45 and 15, 60 plus this radius is 15, so 75. So total height is 75 millimeter. And how much is the width? So total width is directly given by the side view, so it is 70 millimeter. So it is 70. So with this information we'll get length, width and height. With this information we'll draw a reference line. To this reference line, on this reference line locate the origin. From this origin draw two lines on right side and left side, inclined at an angle of 30 degree. In between we'll draw this particular line which is perpendicular to the reference line. On this line, obviously the front view which is visible to the left side, or the left hand side view is visible to the right side of the front view. So obviously front view will come on this side, here we will get left hand side view. So front view will give you two dimensions, length and height, and side view will give you two dimensions, that will be width and height. Okay, so with these dimensions we'll get all three dimensions, length, height and here we'll get width. So that can be used or located in this particular diagram. So here we'll locate the length is 50 millimeter, mark this 50 millimeter, mark width 70 millimeter and height 75 millimeter. So once you have located these positions, complete by using ruler scales, complete the box which you are going to use so as to draw an isometric view. Once you have completed this box, so with respect to the positions of the views which are given to you, we'll first try to locate the information or the points. So in front view you can easily see the continuous lines from origin. So from origin this particular dotted slot is visible to the observer from front. Okay, so directly that can be located, and this dotted shaped slot is for throughout the width, as it can be seen with the use of this dotted line. Okay, so this particular portion is visible to the observer from side, and this gives you the continuous thick lines. So easily we can, at this particular face, we can draw this particular dotted shape and this particular portion. Okay, so this is height 5 plus 10 millimeter. So we'll locate this 15 millimeter here and we'll mark 5 millimeter also, so 15 millimeter. Okay, so by using roller scale we can project this distance. Okay, so once you have located this, obviously, so as to know actual points, that is 36 millimeter and 30 millimeter apart, we must draw the axis line or the axis of symmetry. So axis of symmetry is to be drawn, which is visible to the observer from front. As it is observed by the observer from front, the observer will observe it from top. Okay, so with this position we have to find out the points so that we'll complete the dotted shape slot. So 36 millimeter is at a distance of 5, so 18 millimeter on left side, 18 millimeter on right side, that can be easily located. So here we will get point 18 millimeter, here we will get point 18, 36 millimeter, and here the below the distance is 30 millimeter. So easily we can locate these points. Okay, so we can join these points. And we'll complete this particular dotted shape in isometric view. This is visible to the observer to this point, so which is visible to the observer. Now the 30 millimeter, this portion is at the of radius 15 millimeter. Obviously this distance will be 30 millimeters. So from this point to this point the distance is 30 millimeters. So we'll mark this distance. Fifteen millimeter, 15 millimeter. So up to this point we'll so we have drawn this, but now from this point it is again lifted 10 millimeter above, so which can be shown from this side view. So from this particular, so obviously as we get origin over here, same way in side view we will get origin on this point. So near to the origin it is lifted, so obviously this portion is for throughout the width. So for throughout the width this particular portion is there, so we'll lift this point 10 millimeter above. So this 10 millimeter which can be easily seen from front view. So 10 millimeter will mark. Use your scale properly. So this particular portion is visible to the observer from front, which this I have drawn over here. Now this particular portion is for throughout the length, so we'll draw it for throughout the length, which can be easily visible to the observer from side. So this particular portion we have completed with. Same way this also will darken. Okay, now you can see over here this particular portion which I have drawn over here, it is for up to this much length. So this distance is 40 millimeters, so it can be extended till 70 minus 40, 30 plus 10, 40. So we can extend this particular portion up to 30 millimeters. So we'll mark this line 30 millimeter. So you have to use your instruments properly, then only you will get the proper line. 30 millimeter. So we have easily located this point 30 millimeter. So I'll draw the construction lines from this point. Now from this point it is lifted, so this line which is incline needs to be drawn, but again you have to find out at what distance this line is. So you can, if you have project this line, so these particular two rectangles can be seen or visible to the observer, okay, from front, and from side you can observe it at this at an angle. Okay, so we must know exactly where this point is. So obviously from here, obviously we'll lift this particular point. So this is again 30 millimeter. Sorry, it is somehow shifted, so we'll consider this. So this point we have got over here. So now in side view we can see 10 millimeters. So we'll draw this line 10 millimeter. So this portion is visible to the observer from side for 10 millimeter. Okay, so we'll draw line for this distance. How much is the length? 15 plus 15, 30 millimeters. So we'll draw this for 30 millimeter. So this point which will locate over here, so this point and this point is to be matched, so we'll match this point. So we'll erase this much portion. Okay, so once we have located this point, what next is to be done, that this 10 millimeter and 10 millimeter rectangles, obviously from front we can see rectangles, but from side view it is a slope. Okay, so we'll try to locate this. Obviously we'll move. $10 millimeter, 10 millimeter. So it gets matched. So we complete it like this. Okay, so this is how we have to complete this particular. Now this particular axis line will get shifted, axis of symmetry. Okay, so this particular portion, so observer is observing this particular slot from side view, as it is not visible to the observer, so that's why in orthographic views it is drawn as dotted line. So now a particular circular portion which is to be completed over here. So for that purpose what we'll do, this distance is 30 millimeter. So by using the method of drawing a circle, a circular hole is to be used. So we'll join these points by using the construction method. By using rounder you can complete this arc by keeping pointer at this point and considering this much radius. Same way this arc can also be completed by keeping pointer at this point and radius equal to this much. Same way we'll complete this particular curve. Now this portion is like this, so we have to shift this much, so we can draw like this. So it is same on back side. Same way we can complete the inner hole, which is of diameter 20 millimeter. So 10 millimeter on this side, 10 millimeter on this side, 10 millimeter on this side, 10 millimeter on this side. Complete this parallelogram and complete the circle inside this parallelogram. So it will be completed. So if I darken this and if I erase the remaining lines, how it will look? This is how actually the answer for this question is. Okay, so we have to check that we have drawn each and every line as per the law or rules of an isometric view. Okay, so this much only you have to draw to complete the view. Now you have to give dimensions. So once you have completed an isometric view, we have to give all the dimensions, only those dimensions which are visible on orthographic views. The same dimension should be reflected on an isometric view. Okay, so with this information you have to show finally the position of the observer. So if you consider x as an observer, so this information you have to show. This is how we have to complete the isometric view. Okay, thank you.